The top two bullets on the previous slide highlighted two of the pillars within quality control. The first pillar are control charts, and those are a part of process control. And then the second is acceptance sampling. There's two figures on this slide that illustrate how those work. In the top figure, you have a graph with X bar on the vertical axis, and you have time on the horizontal axis. At regular periods of time, you go in and calculate an X bar, and each of the dots that you see there is one of the X bar values. Over on the far right, you can see the blue line in the middle there is labeled CL, and CL stands for center line, and that's your target. The top line in black there is labeled UCL, and that stands for upper control limit. And the bottom black line is LCL, which stands for lower control limit. Usually, these two limits are 3 standard deviations from the center line. So if you assume that X bar is normally distributed, and you just go to a t-table and say what's the probability of falling within 3 standard deviations of the mean, you get a probability of 99.73% that you are going to fall within those limits. So let's look at a specific setting. Let's say our X bar value of 1/4 comes from the fact that we're going to be calculating the pre-cooked weight at a McDonald's of quarter pounders. That pre-cooked weight is supposed to be 1/4 of a pound, so that's our blue line, that's our center line. And then from previous data, we can come up with an upper control limit and a lower control limit. And then let's say at the beginning of each shift, we go in and we calculate an X bar, and that's what those black dots are. And you can see the black dots are staying within the lower control limit and the upper control limit until the second to last dot, and that one is way high. So at that point, when you get what's called an out of control signal, you then go back to your process and say what happened. So for example, that might correspond to a new employee that was accidentally putting in too much weight into the quarter pounders, and that resulted in the out of control signal. So that's what a control chart is, and the purpose there is to try to keep the process within limits and get a consistent quality. Now down at the bottom is a graphic that shows you a little bit about what's happening in acceptance sampling. Let's say our product has already been manufactured, and those black dots in the urn there represent the manufactured products. Well, we can't sample every single one off of the line, so in acceptance sampling you determine a subset of those items, and you pull out that subset and test that subset. This is pretty typical when a producer is providing a product for a consumer, and the consumer wants some evidence that they have not too many defects within the manufactured item that they are purchasing.